In the previous video, we learned how to perform the data cleaning and transformation tasks. We loaded our data from a CSV file, cleaned, preprocessed, and saved it to a new tab file. Today, we will start with the real data mining. Starting from the preprocessed data, we will extract patterns using a data mining algorithm and then evaluate the results. Using the Titanic dataset, we will apply the decision tree learning approach to classify our data and make predictions. A decision tree is a supervised learning algorithm. It requires that a class label is included in the data. Using this information, it will learn how to split the data in the best possible way. The features are selected sequentially. From each of them, the algorithm will create different branches that split the data based on the feature value. The algorithm will continue until the quality of the splitting is satisfactory. At this point, it will create a leaf to assign a class to the data. In our Titanic dataset, our class value is included in the survived field, as we already seen in the previous video. A decision tree will be learned from the dataset. As you can see from the simplified example, our algorithm may first choose to split the data by the sex feature, then by age to finally find a decision on the survival of the passengers. In this case, we can say that the female child under 2 years old age were likely to survive. One advantage of the decision tree's algorithm is that it is explainable. By following the branches of the tree, you can find the reasoning and motivation for the final labeling. Now, let's see how to do it in Orange. Let's start by loading the dataset we cleaned in the previous video. We use the File widget. After selecting the correct file, let's check the results on a data table widget. Double-click on it, and perfect! Our data is loaded correctly. Let's first perform an explorative data analysis step. We will do it by using the Correlations widget from the Unsupervised panel. This widget will compute the correlation between the different features in our dataset. Here, we can check if our data makes sense, and at a later stage we will use it for selecting the correct features for our task. Double-click on it. As you can see, the fare and P-class features are negatively correlated. It means that when the fare price raises, the passenger class lowers. This makes perfect sense, as the first class is more expensive than the second class. More interesting is to see that also the age and the P-class are negatively correlated. It means that the younger people were traveling in second and third class, while older people in first class. The same is confirmed by the positive correlation between age and fare, where older people can afford more expensive tickets. Now, let's start our data mining to discover something about our data that we don't already know. Let's put on the canvas a Select Columns widget from the Transform panel. Connect it to the File widget and double-click on it. To start, let's leave on the feature box only the P-class, sex, and age features. Our target class remains the survived class. We don't need the metas either. Bring them to the ignored side. We do this to keep our decision tree analysis simple. We will see later how it impacts the quality of the analysis. Let's put a tree widget on the canvas. You can find it in the Model panel. Connect it to the Select Columns widget. If you double-click on it, you can find the various parameters to play with. Each of them will impact the inner working of the algorithm. We can leave them to the standard values. Close this window and let's check the results. Let's see the results by using Tree Viewer widget. You can find it in the Visualize panel. Now double-click on it. Here you can see the real structure of the tree that the algorithm discovered. Put it full screen and adjust the width and the zoom using the sliders. Let's try to follow one of the line of reasoning of our decision tree algorithm. The number on top indicates the class value, the survived code. Remember, a value of 1 is for the survived people and 0 otherwise. The percentage and color of the box indicate the strength of the decision. The closer to 100%, the better it is. If we follow the leftmost branch, we can find that the first split is made on the sex feature. For female, we will further split on the age feature. If age is lower or equal than 14.5 years old, we should check the P-class. If the P-class is lower or equal than 2, we can quite safely say that the passenger survived to the disaster. In this way, our algorithm found an explanation for the survival of all the passengers on board, and we can make a decision appropriately using a data-driven approach. But now, think about it. Something happened there. Basically, we didn't predict anything. With this procedure, we just fit our data to a decision tree. It's perfectly fitting the information in our dataset. We can also manually use it to predict the outcome for a new passenger. But we don't know how good is the prediction. In the next video, we will see how we can use the decision trees to make the predictions. That's all for now. Ciao!